Welcome back to a second video on integration by substitution. I thought we should take a look at some additional examples. This first problem is a definite integral, and we're going to let u equal the inner function as recommended. So u is going to equal 2x plus 1, and we'll see what this does. Differential u would be equal to 2 dx. Looking at our integrand, we have 1 dx if this is equal to u. So I'm going to go ahead and divide both sides by 2. So 1/2 du is equal to dx. So again, this is our u, and 1 dx is equal to 1/2 du. So let's go ahead and rewrite this. I'm going to go ahead and leave off the limits of integration since these are limits of integration with respect to x, and we're writing this in terms of u. So we'll have 1 over the square root of u, which is u to the 1/2, and then 1 dx is equal to 1/2 du. Let's go ahead and rewrite this as u to the negative 1/2, so we can apply the power rule. So here we'll have 1/2 times u to the 1/2, but u is really 2x plus 1, so we'll have 2x plus 1 to the 1/2 divided by 1/2, evaluated at 4 and 0. Well, the 1/2 simplify out, so we're left with the quantity 2x plus 1 to the 1/2 power. So we'll first replace x with 4. 2 times 4 plus 1 would be 9. So 9 to the 1/2 minus 2 times 0 plus 1, that will be 1 to the 1/2. Well, the square root of 9 is 3, the square root of 1 is 1, so this is equal to 2. Let's go ahead and take a look at another one. Now in this one we have two composite functions, but since the derivative of sine x is equal to cosine x, let's try letting u equal sine 2x. Well, to find differential u, we are going to have to apply the chain rule. So the derivative of sine u is equal to cosine u, or in this case cosine 2x, times u prime. Derivative of 2x would be 2. Looking back at our integrand, we have cosine 2x dx, so I'll go ahead and divide both sides by 2 here. So we have 1/2 du equals cosine 2x dx. That'll be a perfect match for our integral. So in terms of u, the blue part would be u, and the red part would be equal to 1/2 du. So now we can integrate. We have 1/2 times u squared divided by 2 plus c. Let's rewrite this in terms of x, so we'll have 1/4. U squared will be sine 2x squared. Or if we want, we can rewrite this as 1/4 sine squared 2x. Those would be equivalent. And let's take a look at another one. Now this one's a little more challenging. If we try to let u equal 4x, du would be equal to 4 dx, which doesn't match. If we let u equal the entire denominator, that wouldn't work either. So in this problem, what we're going to have to do is rewrite this as two different integrals. So the first integral would be 3 divided by e to the 4x, and the second would be e to the x divided by e to the 4x. Now let's go ahead and factor out the 3 on this first integral and move the exponential part up into the numerator, so we'd have e to the negative 4x. And on the second integral, these bases are the same, so we can subtract our exponents. X minus 4x would be e to the negative 3x. Now I think we can use u substitution. Here if we let u equal negative 4x, then du would equal negative 4 dx. Now we don't have a negative 4 dx, so let's go ahead and divide by negative 4. So that tells us that negative 1/4 du equals dx. Now for the second integral, let's go ahead and use v instead of u to avoid any confusion. let's let v equal negative 3x. Then dv will equal negative 3 dx. And again, we just have dx, so let's go ahead and divide by negative 3. So we have negative 1/3 dv equals dx. Let's go ahead and rewrite these in terms of u and v. So the first integral would be 3 times, this would be e to the u, and then dx is negative 1/4 du. So we'll put the negative 1/4 here, du here. Minus, again, this is going to be e to the v, and dx is equal to negative 1/3 dv. Let's go ahead and continue up here. This is going to be negative 3/4. Now the antiderivative of e to the u is just e to the u. So this is going to be e to the negative 4x. Here we have minus a negative 1/3. That'll be plus 1/3. And the antiderivative of e to the v would just be e to the v, which would be e to the negative 3x, and then plus c. Okay, that'll do it for that one. I think we have time for one more. Again, it's always helpful if we know your derivatives. For example, on this problem, if we let u equal cotangent x, and the derivative of cotangent x is equal to negative cosecant squared x. And that's a very good match for us because we do have a cotangent squared x dx. So let's go ahead and divide both sides by negative 1. So we have negative du is equal to cosecant squared x dx. Let's go ahead and perform the substitution. So cosecant squared x dx is equal to negative du. And then cotangent x is equal to u, so we'd have 1 over u to the third. If we move that up, we'd have u to the negative third. And now we can integrate this. So we'd have negative, add 1 to negative 3, that's going to be u to the negative 2 divided by negative 2 plus c. Rewriting this in terms of x, so this would become a positive 1/2, and then we'd have u to the negative 2, and again u is cotangent x. Let's go ahead and rewrite this one more time. We could move this down to the denominator. We'd have 1 over 2 times cotangent squared x, and of course plus c. Okay, that'll do it for this second video on integration by substitution. I hope you found it helpful.